In this video, I'm going to discuss the topic of filters. These are circuits which allow certain frequencies to pass through but block out other ones. You might wonder why we want to do this, but the reasons will become more obvious in later videos. However, two simple examples will illustrate some of the reasons for doing it for now. Firstly, suppose that we are building a radio or a television receiver. One of the first things that we'd like to do is select the correct station on its allocated frequency and recheck the others that we don't want to hear. This is a good application of filters. As a second example, supposing that we are monitoring a signal from a sensor, which is measuring, let's say, temperature, and there's an interfering signal from another source getting in the way. If the interfering signal is present on a defined set of frequencies, we may well be able to filter it out and so get better quality of a signal that we'd actually like to process, the one from the sensor. So, having looked at these couple of examples, let's say that there are four basic types of filter which we can use in order to let through or get rid of frequencies that we don't want. The low-pass filter allows low frequencies through while rejecting high frequencies, and is represented in a block diagram as shown. It can also be shown in the form of a graph. The band of frequencies which are allowed through are called the pass band, and those which are stopped are called the stop band. A simple example of a low-pass filter is the treble control on an audio system. This allows the listener to attenuate the treble or high-pitched frequencies in the sounds that you hear. The second type of filter is called the high-pass filter, and this just does exactly the opposite of a low-pass. It allows high frequencies to pass through unaffected and stops lower ones from passing through. Similarly to what we just described above, the bass control of your audio system allows you to turn down the low frequencies and is an example of a simple high-pass filter. The third type is the band-pass filter. This rejects both high and low frequencies but allows ones in the middle to pass through. The tuning control of a radio, which we described previously, is an example of this. It only allows a wanted radio station frequency to pass and rejects all the others. Bandpass filters can be made by combining low-pass and high-pass types. The final type is called the notch filter, and this is also referred to as a band stop filter. It's exactly the opposite of a band pass filter. It cuts out one frequency or band of frequencies in the middle, but allows others to pass through. The filter described earlier, which cuts out interference affecting a sensor, might be an example of a notch filter.